I hope everybody is having an awesome day. We are still in chapter 23, and this is over the small intestine. So, the small intestine is the major organ of digestion and absorption. It's about 2 to 4 meters long, which is about 7 to 13 feet, from the pyloric sphincter to the ileocecal valve. And the ileocecal valve is the point at which it joins the large intestine. It has a small diameter, about 2.5 to 4 centimeters, which comes out to about 1 to 1.6 inches. There are three subdivisions: the duodenum, the jejunum, and the ileum. The duodenum is about 25 centimeters or 10 inches long. It curves around the head of the pancreas, and it's the first part of the small intestine. The jejunum is about 2.5 meters or 8 feet long. And the ileum is about 3.6 meters or 12 feet long. And the ileum joins the large intestine at the ileocecal valve. So we have the duodenum, the jejunum, and then the ileum, which connects at the ileocecal valve. So the blood supply comes from the superior mesenteric artery, and then veins drain into the superior mesenteric veins, and then into the hepatic portal vein, and finally to the liver. The nerve supply, the parasympathetic innervation is via the vagus nerve, and sympathetic innervation is from thoracic splenic nerves. So there are some modifications of the small intestine for absorption. And the small intestine's length and other modifications, which we're about to talk about, provide a big surface area for nutrient absorption. The surface area is increased 600 times to about 200 meters square, which is the size of a tennis court. The modifications include circular folds, villi, and microvilli. Circular folds or permanent folds are about a centimeter deep, and in inches, that would be like a third of an inch, maybe, that force chyme to slowly spiral through the lumen, which is going to allow more time for nutrient absorption. The villi are just finger-like projections of the mucosa, and they have a core that contains a dense capillary bed and a lymphatic capillary called a lacteal for absorption. And hopefully you remember lacteals from the lymphatics chapter. And then there are microvilli, and these are cytoplasmic extensions of the mucosal cell, and they're going to give the cell a fuzzy appearance called brush border. And this is going to contain membrane-bound enzymes, brush border enzymes, that are going to be used for final carbohydrate and protein digestion. And so I had a cursor and I lost a cursor. There we are. These are the villi. Hold on, I'm trying to get the cursor back. There we go. These are the villi. Here, little finger-like projections. And that's what we're seeing here. There we go. So this is a villus. And then if you were to take an image like a section here and blow that up, you would see the microvilli. This is also cursor. There we go. This is a villus, and these are microvilli. Each one of these are microvilli that form the brush border. So the modifications of the mucosa and the submucosa of the small intestine do reflect its function in digestion. And what that just basically means is the anatomy is such that the small intestine can absorb a lot of material. There are also intestinal crypts, and these are tubular glands scattered between villi. And there are 5 main types of cells found in villi and in crypts. And there are the enterocytes, goblet cells, enteroendocrine cells, Paneth cells, and stem cells. I deleted all the detail about this because you do not need to learn the detail about those 5 main cell types. There's also mucosa-associated lymphoid tissue that's going to protect the intestine against microorganisms. This is going to include individual lymphoid follicles and then Peyer's patches. And I hope you remember Peyer's patches because, again, we talked about this in the lymphatics chapter. And these are going to be located in the lamina propria. And they're found in great numbers in the distal part of the small intestine, the ileum, where bacterial numbers increase. And this is just so that it helps to make sure that the bacteria from the large intestine does not end up in the small intestine. The lamina propria also contains a large number of plasma cells that secrete IgA. The submucosa contains or consists of areolar tissue, and the duodenal glands of the duodenum secrete alkaline mucus to neutralize acidic chyme. So about 1 to 2 liters of intestinal juice is secreted daily, and this is going to be in response to distension or irritation of the mucosa. And again, distension is stretching. A major stimulus for production is hypertonic or acidic chyme. And the intestinal juice is going to be slightly alkaline, and it's going to be isotonic with blood plasma. It's going to consist largely of water, but it also contains mucus, and the mucus is secreted by duodenal glands and goblet cells of mucosa. So now we're going to move on to the digestive processes in the small intestine. The chyme from the stomach contains partially digested carbohydrates and proteins and undigested fats. So remember, carbohydrate digestion begins in the mouth, protein digestion begins in the stomach, and we also have some lipases are secreted, but it's going to be mostly undigested fat. It's going to take about 3 to 6 hours in the small intestine to absorb all the nutrients and most of the water. And then the sources of enzymes for digestion include substances such as bile, bicarbonate, digestive enzymes, and these are imported from the liver and the pancreas. And then brush border enzymes bound to plasma membrane perform the final digestion of chyme. So chyme entry into the small intestine is regulated. Chyme entering the duodenum is usually hypertonic. Therefore, chyme delivery has to be slow to prevent osmotic loss of water from blood. The low pH of chyme has to be adjusted upward, and the chyme has to be mixed with bile and pancreatic juice to continue digestion. The enterogastric reflex and enterogastrones control the movement of food into the duodenum to prevent it from being overwhelmed. Motility of the small intestine. After a meal, segmentation is the most common motion of the small intestine. Between meals, it's going to be peristalsis, and that's going to increase. And this is initiated by a rise in the hormone motilin in the late intestinal phase. And remember, peristalsis is just alternating contraction and relax. So it contracts, moves the food, contracts, moves, I should say foodstuffs, moves the foodstuffs, contracts, moves the foodstuffs. And then segmentation is where we're kind of splitting off and we're going to be mixing foodstuffs with digestive juices. The ileocecal sphincter relaxes and admits chyme into the large intestine, And then this is just showing the control of small intestine motility. And then here, this is an overview of the functions of the gastrointestinal organs. This is going to start with the mouth and go all the way to the large intestine, which we have not covered yet. And that's all I have for this talk, but here are your questions.